All right, so good morning, student. This question is a multiple choice question. And first, I will enlarge the image so that you can read the question and I will read it alongside. Let's see what is the question. All right, so there is a skater of mass m standing on the ice, okay, throws a stone of mass m is equal to 2m. So the mass of the stone is double the mass of the skater with a velocity of 5 meter per second in horizontal direction. If the coefficient of friction between the skater and the ice is zero point 0.5, find the distance over which the skater will move. Take g is equal to 10 meter per second square. Okay, read it carefully. Let me just draw the situation so that it is clear in our mind as to what we are trying to achieve in this question. All right. So let's say there is a skater. Okay, I will draw a very rough figure of the skater. So this is the skater, and the skater is on the ice. So this is your ice. Okay, that's your ice, and I will just show the ice with these dash. The skater throws a stone. The mass of the skater is how much? The mass of the skater is m, and the I'm just showing it. It's a point mass for all practical purposes. So the stone which you have thrown is equal to 2m. That's what you're doing. You're throwing a stone, and underneath you have ice. I hope you have read the question and you have seen the choices. Our aim is to find the distance through which the skater will move as a consequence of this throwing of the stone. So let's analyze the question. Okay, let's see what exactly is happening. And the purpose is to, you know, get you into a mind of being able to think the concept. Okay, so if you throw a stone, right? Generally, I didn't move, right? I didn't move because I throw something. For example, anything I generally don't move. But on the ice surface, I am able to move because the friction is very low. So what exactly is happening? If I throw something, why should I move at all, right? That's the first question. You need to think why I will move. That is the way you approach a physics problem. Just don't blindly start writing formulas. Friction, it's a friction question. For all you know, it may be a different scenario, right? Different concept to start with. Friction is involved, so it gives you a hint of friction being involved. But first thing first, right? Why do you move when you throw? The reason you move in this question, you have to think about it. You're doing mechanics, okay? In any situation where if you throw the stone with some velocity, I think the velocity with which you have thrown is 5 meter per second, right? So this has been thrown with 5 meter per second. This is your velocity, okay? The thing, Newton's first law, right? The body continues to be in the same state of motion or rest unless there is an external force applied. Does it make sense? Does it make sense to apply Newton's first law? A body? No, it doesn't, right? But let's go to the next one. And therefore, let's move to the second law. The second law states a body changes its momentum if there is an external force on the body, right? The rate of change of momentum is the external force. If you notice, I didn't see any external force in this question. I didn't see the skater being pushed. Nobody's pushing me. On the contrary, I'm just throwing the stone, standing on the ice. So, second law of motion per se, in itself, from external force point of view, doesn't make sense. Now, let's think in terms of third law, the Newton's third law. Every action has equal and opposite reaction. Okay, so this actually is close to what is happening probably, right? I'm throwing and I'm getting pushed back, something like that, right? But there is no external force. That's a conundrum. That's a dilemma we have. It looks like an action and reaction, but there is no uh, external force. Let's move to other things. Let's go to law of conservation of momentum. Okay, in a collision or in a closed system, or a closed system having no external force conserves its momentum, right? Let's see the momentum of the skater. Okay, the skater, we don't know what is the momentum of the skater, but we know it seemingly the skater gets a jerk which is backwards for some reason. We will think. Let's talk about the momentum of stone. The stone momentum is 2m multiplied by 5 is equal to 10 kilogram meter per second. And I will just write it as into m, right? So it's 10m. That's the momentum of the stone in positive x-axis. And the law of conservation of momentum tells me if it's a closed system, if there is no external force, you are likely, you're not going to have any external force there. The momentum will remain conserved. Law of conservation of momentum. So if I say the momentum of stone plus the momentum of skater, okay, is equal to zero. It should be zero, right? There is no external force. So that means the momentum of skater should also be equal to 10m, right? Same as that of the stone which is thrown, but in the opposite direction, because this will go on the other side, and therefore P skater will become minus 10, right? This equation is the equation of law of conservation of momentum. So the key concept in this question is law of conservation of momentum. So these two are equal, and therefore the momentum of the skater can be written as mass of the skater, okay, multiplied by the velocity it gets back, okay, is equal to, so it's a backward, that is for sure. So I'll put a negative sign if I have to. But that is more to do with sign convention. If you're just talking about magnitude, you can straight away calculate it. So this is 2m multiplied by 5, which is 10, right? So n goes away. So the velocity of the skater is 10 meter per second in the backward direction. Okay. What's your lesson learned? Your lesson learned is that you find external forces. If you don't find any external forces, it should evoke a feeling inside you that if there is no external force I can see in the form of a tension, a push, or a pull, or stuff like that, this is likely a law of conservation of momentum question. Okay, so that is first thinking that you need to do. All right, now that we know the momentum or the velocity of the skater in the backward direction. So let's come to the second topic of it. How far will he move? Now, obviously, the skater has a friction down below on the surface, which means the skater will finally stop. Which means there is an external force. Somebody is decelerate. Somebody, which is friction, not somebody. Physical quantity like friction is going to decelerate the man, okay, or the skater. So here is a, so if you're tending to go in the leftward direction because of this backward jerk, okay, then what is going to happen? Just give me 1 second, okay. All right. So if you're going in the backward direction, okay, which is this, and let's see what happens. You are going in this direction. In the backward direction is your velocity. So you're going like this, obviously on the skates. The frictional force will act in this direction, right? So this is your mu r, right? So the frictional force which is acting on you, right, is in the opposite direction to your motion. You are going back, but the friction is acting. So this becomes a case of deceleration, right? So mu is mu r, and the coefficient of friction which is given in the question is equal to 0.5, right? So your mu is given to be 0.5, right? So let's use this to find the value of the distance by which you will move. All right. So let's look into it. So the total force of friction, okay, F is equal to mu n, right? Or R. R is your, so 0.5 multiplied by your mass multiplied by 10. I think G is given to be 10, right? So this is your total force of friction. This is your frictional force in Newton. Okay. What is your deceleration divided by? So your deceleration comes out to be the total frictional force, and the only external force now acting on the skater is frictional force. You can see there is nothing else. Obviously, the weight is there, and weight is vertical, right? The horizontal motion is being described here. So A is equal to 5 m divided by 5, which is the, sorry, n, which is the mass of the skater, is equal to minus 5 meter per second square. Okay. What do you do now? Finally the skater will stop. Once the skater starts moving backward and experiences a force of friction, what will happen? At a certain place, the skater will come to rest, which means the final velocity will become zero. What is the initial velocity? And this is the case of uniformly decelerated motion, because if the frictional coefficient of friction is not varying, it is constant force being applied on you, right? Of deceleration. So your initial velocity, which you calculated from the formula, was 10 meter per second squared. This came from law of conservation of momentum. Your deceleration is coming out to be your force of friction divided by your mass, which is minus 5. Minus 5. Therefore, v squared minus u squared is equal to 2as. So your final velocity is 0. I think, let me change so your initial velocity now is equal to 10. So this is 0 square minus 10 square is equal to 2 into minus 5 into s. So this is minus 100 is equal to minus 10s, and this goes away, and therefore s is equal to 10 meters. So the skater will move through a distance of 10 meters. So is there a choice? Yes. So the choice number C is the correct choice. I could have solved this question in one line, right? But what is the uh, point of this video? If I were to solve this without making you understand how to think in mechanics numerical. In mechanics numerical, where you're given friction, a person throws, push, pull, etc., you should know how that is acting on the body. But you should know what's the logic inside you. Is there an external force? How to deal with external force like tension, you should know. Is there an external force like a push? How do you deal with that? You should know. Is there an external force like friction? You should know how to deal with that. So on and so forth. But if there is no external force, the second logic is, if all of this is internal, which is I throw in the, I get a jerk back, what exactly is happening? It's a law of conservation of momentum. So think like first law, second law, third law, conservation of momentum, uh, work energy principle, law of conservation of energy. Club all of these. Think logically. If something is striking you clearly and distinctly, that's the way to the solution. So I hope you enjoyed this video. I give detailed explanation of the questions, just not the solving them to impress you, but to actually ensure that the concept stays with you forever. That is, the retention becomes very, very high. I mean, it doesn't take away the fact that you don't have to practice. You still need to practice. On my channel, you have 3,000 videos for class 11th and 12th. That is an Indian class system. But if you're IB board student or AP physics or preparing for NEET and JEE, it's equally applicable to you. So you have variety of questions, a plethora of questions for you to understand, analyze, and learn from. So thanks a lot. Don't forget to subscribe to this channel. Spread this channel to your friends who are interested in physics and want to make career by strengthening physics. Physics is going to get used all your life. So even if you're a doctor, you're tested for physics through an examination. So thanks a lot again, and see you soon.